Hello guys, am I audible? Okay, okay, I'm on. Good evening everyone. Good evening guys. So what we'll do today is we'll be solving some interview problems on linked list. So mostly we'll solve problems from LeetCode. So these problems have been asked in interviews a lot of times. Okay, so we'll just start this session. Okay. So let's see. So what I'll do is before I start this, so let's give a brief introduction about myself. So my name is Arkapravo and I will soon be joining postgraduate studies in computer science at IIT Kharagpur. So I have more than 3 years experience in competitive programming. Like I have been to several contests like SM, ICPC, Code Jam and many other contests. So these are some of my credentials. I'm currently rated 5-star on Code Chef and expert on code courses. Okay. Okay. So let's start this session for today. Let's start this. So let's see the first problem for today. So this will be the first problem. Okay. So what I'll do is I will just share my screen and I will also send the link in the chat. If you want to open the problem separately, you can do that also. I hope the problem is visible to you. So go through the problem, take your time. Is the problem okay? So let's go through this. So what we are given is we are given a linked list and we are given an integer x. Okay. So basically what we have to do, we have to form two separate parts from this linked list. The first part will contain all the integers, like all the nodes which have values less than equals to x, and the second part will contain the nodes which have a value like greater than equals to x. Let's look at this. So this linked list has got these values and our target value x is 3 here. Okay, so we separate the node like the first part contains 1, then 2, and then again 2, and the second part contains the values which are like greater than equals to x. That means 4, 3 and 5. So basically we are just dividing the list in these two parts. And one thing we should note that all, like, we should preserve the original relative order of the nodes. That means 1 comes first, then 2, then these 2. So this should be maintained: 1, 2, 2. Then there is 4, 3 and 5. This is the order of these nodes. This should be maintained: 4, 3, 5. Okay, so this is what we have to do. Like, and let's look at another example. 2 and 1, this is a linked list and x is equals to 2. So what I have to do here, the first part will contain all the values less than 2. So the only values less than 2 here is 1. So the first part will contain 1, and second portion would contain all the values greater than equals to 2. That means it will contain 2, and there is just one value 2 here, so it will be 1 and 2 like this. So is the problem clear, guys? Like what you have to do here? Sort of, this class has started just now. We started at just like 7 p.m. So what do you think of this problem? Can you solve it? Do you have any idea how we can solve this problem? Take your time, take 3 minutes, 4 minutes, try to think what we can do here. So is the problem clear, guys? First of all, tell me in the chat if there is some doubt, or you can write yes if the problem is clear. So is this problem clear, guys? Just tell a yes or no in the chat. Please, 1 second. Okay. Yeah, sure. So I will just explain here. So it is given that we are given a linked list. Let's say like this. Let's say we are given this linked list and this is null. So what you have to do here, basically, we are given uh, an integer x, okay, along with this linked list. Let's say x equals to 3 in this case, okay. So what you have to do, you have to divide this list into two portions such that the first half contains all the values less than x, and second half contains all the values greater than equals to x. So if we change this linked list, modify this linked list in this given order, so this linked list will look somewhat like this: 1 2 2 4 3 and then none. So look at this, these values like 1 2 and this 2 are less than equals to 3, are like less than 3, so they are coming first here, and these values 4 3 and 5 are greater than equals to 3, so they are coming later. And just note one thing, that the relative ordering of these nodes is maintained. That means 4 comes first, then 3, then 5. So here 4 comes first, then 3, then okay, sorry, I'm this will be 5. Okay, so now it is clear, I guess. So Aditya is saying you can print the values. No, we don't need to print the values. What we have to do is we have to return the linked list. We have to return this modified linked list. So we have to return a pointer to this linked list. Okay, we have to create a new linked list which will look somewhat like this. So this we have to return the head of this linked list. So take your time. Take I will show the problem screen here so that you can think about it for a moment. Yeah, this is the problem. I will give you 3 minutes. If you have any approach till then, you can tell me in the chat. So try to take a pen and paper and see for yourself what you can do. You want to do this in linear time, like O of n. So if you have a pen and paper handy, it will be helpful. So what do you think of this, guys? Anything? Any idea how you can solve this in linear time? So I will give you 2 more minutes and then we'll look into the solution. Any idea, anyone? You can write in chat. I am following the chat. Any, like anything which comes in your mind, you can tell me. No issues. No idea. Write something in chat. What you are thinking, how you can solve it. Maybe it is wrong. One list for less than. Yes, Bhuvnesh, you can do that. You can do that. Like, so you're correct, Bhuvnesh. Okay, so what we'll be doing here is let me write this here again. Okay, let me not drop this. So if we have a list like this and x equals to 3 here, so what we'll do here basically, we will just keep 2 lists. Okay, we'll maintain 2 lists. Let's say first list is p and second list is q, p and q, and the idea is to traverse through the given list, like each node at a time, and we'll check that if this value is less than x, we'll just append this node into our first list, and if the value is greater than equals to x, we'll append the value, like the node, in the second list. So now we have two lists. This first list will contain all the values which are less than x, and second list is going to contain all the values which are like greater than equals to x. So if we get this, so after that we can just combine these two lists, like this list will be p and this list will be q, like all values less than x, all values like greater than equals to x. So if we can just do this, our problem will be solved. What do you think? So let's see this. So now we are looking at the first node. It is 1, right? Less than x, less than 3. So append this node into the first list. Now next value 4, like greater than equals to 3. So put it into the second list. Now 3 is greater than equals to 3. So put this node into our second list. Now go to this value 2. This value will be less than x. So put it here. Next value 5 greater than equals to 3. Put this node here. Last value 2 less than x. Put this node here. So we now have these two lists at our disposal. Now what we'll do? Simply link this to here and make this point to null. See if we can do that. Now do we have this list? 1, 2, 2, 4, 3, 5. So if you look at this list pointed by p, you basically have this list 1, 2, 2, 4, 3, 5, right? So do you see how you can solve this problem? And we just have to maintain two lists. So, and we're just iterating over this entire list one time. So you just iterate from left to right one time. So it will be O of n, right? Do you have any doubt, guys, or is this solution clear? So is it clear, guys? Tell me if it is clear. Otherwise, I will explain again. So ultimately, what we'll have here, I will draw it. You will have these two lists. You will have just this list, okay? And you can return the list pointed by p. Okay. So do you want to look at the code, or we'll go to the next problem? Okay, so I think now we can go to the next problem, or maybe I will just show the code if like I have got no response from you guys. So I will just show the code to make it more clear. Yeah. So what we are doing here, we are maintaining like two lists p and q. Initially they are pointing to null ptr, and this start p and start q are two variables which we will use to point at these two lists p and q. So we just iterate over this linked list, and every time if we say that the value is less than x, if p is null, that means the like corner case, when the first node actually. So we make this start node and p equals to head. Otherwise we put this node towards the end of the list and just update this p to point to the last node of our list currently, okay? Otherwise, like if it is greater than equals to x, we do the same thing with just the second list q, okay? So if q is null, make this point to the head, start queue and also queue. Otherwise, add, like, append this current node head to the end of the second list. Q next equals to head, and update the queue pointer to point to the last node currently. Q equals to queue next. This is, in this way we just iterate through the entire list, and after this is done, we just do a check. That means if the first, that means the list pointed by the first list actually then is null. So basically it means that there is no value which is less than x, is not equals to null. So we will add this, right? We'll make this link, actually. So if start p not equals to null, p next equals to start q. Else, that means else if it is null, we'll just make start p point to the second node. Okay, we'll just make the first list point to the second list because it is null. That means there is no value. And if start q is not equals to null, we just make the last node point to null. That means last next equals to null, and simply return this node. So I hope this is clear. Very simple code, very simple implementation of our logic. So if it is clear, let's move on to the next problem. Any doubts, guys? Tell me, or else let's look at the next problem. So let me share the link with you in the chat. So now we are solving some medium level problems, but towards the end of this will be, like, towards the end of this session, what we'll do is we'll look at some medium and hard level problems. We are starting off with easy medium level questions, and we'll move to some medium and hard level problems toward the end of the session. So this is the problem. Let's see. Given the head of linked list, remove the nth node from the end of the list and return its head. So if n equals to 2, we have to return the second last node. That means second last node is 4 here. So just remove this 4 and return the linked list 1, 2, 3, 5. So here n equals to 1 means the last node. That means there is just one node in this linked list. So just remove that node. So here are two nodes, 1 and 2. Remove the last node, n equals to 1. So just this node is removed, 2. And the linked list with content was 1 node 1. Okay. So if we remove the nth node from the end of the linked list, and we have to do this in O of n time and just one single iteration of the entire list. We have to do this in one iteration. Okay. You cannot iterate the list like many times. Just one iteration, you have to complete this deletion. So that is the main thing. So this problem has been asked in interviews quite some time, and also the previous problem has been asked. So tell me, think about this problem, think about it, how you can delete this node in just one iteration. So I will give you guys 2 or 3 minutes to think. Everyone think of it, how you can solve this in one iteration, and you can put in your thoughts in the chat. So I will just wait for everyone to come up with an approach. Bhuvnesh, you can do that. That will work. So any problem guys in this, like if you have any doubt, or are you guys thinking? So let's give you 2 more minutes. If you are thinking, you can tell me what you are thinking, your thought process. You can tell in the chat. So any ideas, anyone? Okay, so like others, what do you think of this? If you have, just tell me in chat what do you think, how you can solve this in one iteration, or like any approach you have in mind. Iterate n minus 1 time. No, we have to delete the nth node from the end. I did this question, not from the beginning. K minus 1. No, no, you have to delete the nth node from the end, not from the beginning. Nth node from beginning will be just traverse n minus 1 nodes, delete the nth node. You have to delete this node from the end, okay? So I think everybody is thinking I would delete the nth node from beginning. Read the question carefully. Remove the nth node from the end of the list. Yeah, Mayur, you can do that, but that would take 2 iterations. You have to first iterate once to find the length of the list, and then again iterate and find the length minus n plus 1 node. But I just want to iterate just one time throughout the entire list and delete it. That is a perfectly correct approach, but it just needs 2 iterations. So you want to do it in a better way, one iteration. And I think everyone others that it is clear, right? We are deleting the nth node from the end, not from the beginning. From the beginning, it will be a different case. It will be very simple. Just delete the nth node. Okay. So let's discuss the approach now. What we can do here, basically, the idea. So if you have some nodes like this. Maybe let's say we have a linked list of, let's say we have some values. I don't care what the values are. Okay, let's say the length of this is length, and I want to delete the nth node from n. Let's write here delete nth node from n. So this length, I don't know this from the beginning. Okay, I don't know this from the beginning. So I will just, okay, so what we can do is we can keep a pointer. Yeah, you can reverse, but reversing will also take one iteration, and one iteration of the entire list. So I don't want to reverse it because it will take just one iteration, right? And then in the second iteration you have to again go and delete. So what you can do, you can take a pointer p and go in nodes and make this pointer move in nodes. Okay, so this pointer will iterate first n nodes. Okay, now this pointer is standing at this point. So if the length of the list was x, let's suppose x, because we don't know what the length of the list was. If it was x, then there are x minus n nodes remaining in this portion. Okay, so now p is at this point. So let's cut p from here after n nodes. Now you make another point at this node. Okay, and what you do now, q is pointing here and p is pointing here. Now you make p move to the end of this list, and for every move of p you also move q by 1. So let's say there are some nodes, and let's say the list was like this. So now p is here. Now for every iteration of p, now when p moves here, q also moves one node. P moves here, q moves here. Finally p moves here and q will move to the next node. Okay, so when this p is iterating over this x minus n nodes, now this q will iterate how many nodes? X minus n, correct? So there are x minus n nodes towards the right. Now as p is iterating this x minus n nodes, so also q will move x minus n nodes from the beginning. So basically there will be n nodes remaining towards the right of q after this iteration. So if you have any doubt, okay, I will just explain to you. Just give me a second. So after this iteration, so there will be n nodes remaining after this queue. Okay, now look at this. Now this node will be the node to be deleted because there are n nodes here. So 1, 2, 3 up to n. So this will be the node which you have to delete. So we just take one pointer p, move it n steps, and then we keep another pointer q toward at the head of the list, and as we iterate this p towards the end of this list, we also iterate q like along with that p. For one iteration of p, the q will move one time. So now after q moves this x minus n times, there will be n nodes remaining, and now you have to simply delete the first node here. So if you remove this node, so basically you have deleted the nth node from the end of this list. So is it clear, guys, how you can do this in just one iteration? If you have any doubt, you can tell me. Tell me if you have some doubt, or if it is clear, then also you can tell me. Is it clear, guys? Please explain how to move p. Okay. So let's take this example and see what is happening. 1, 2, 3, 4. So delete the second node. Okay. So delete the second last node. So what I do, I take a pointer p, I make this pointer move. So it is, so this is n. Okay. So I make this pointer move n minus 1 time. So this pointer is initially pointing at here, and it will move one time. So this pointer will point here now. Okay. It is moving n minus 1. Okay. Now at this point I keep another pointer q here. So for every iteration of p, q will move one time. So now p is moving one time here. So p is here, q will be here. So at the end, when p is here, q will be here. Okay. So like as p is moving once, q is moving once. So when this is happening, now it means we have to delete this node. This node pointed by q will be the nth node from the end, right? So to delete this node, what we can do, we can simply copy the contents of the next node in this node. You can simply copy, like replace this value by 5 and make this pointer point here, like copying over the contents of next node and then deleting this node. So is it clear how we can do this? Or maybe like another way can be, like you can take care of this, like you can move n minus 2 steps. That means if p can move n minus 2 steps initially, and then q will start moving. So if you do that, like then q will be at this point. then. Okay, okay, sorry. Let's see. I think, okay, just give me a second. You can do this. This approach actually works. Okay, so I will do what is, I will show you the code that will make it more clear. So we keep two pointers, slow and fast. Fast pointers means which is moving ahead, and slow is the one which is like this Q. So this P is fast pointer and Q is this slow pointer. Basically, you can name it anything you want. And initially, this P pointer, the fast pointer, is moving n steps, as we saw. Now, after moving n steps, if fast moves to null, that means if fast is equals to null, this means nothing but fast equals to null PTR. So if that is the case, it means we have to delete like the nth node from the end. So if there are like 4 nodes, you have to delete the 4th node from the end, which means the fast node, right? Which means the fast node, if there are 4 nodes and you have to delete the 4th node from the end, then after iterating n times you will reach the end of the list. That means you have to delete the first node of the linked list. So what we will do, we will delete the head of this linked list, make head point to head next, and simply delete this and return head. So this is just a corner case which you have to handle. If fast is equals to null, that means you are moving the, like you are covering the entire linked list. Otherwise, now what we will do, while fast next, we will move fast by one time and slow by one time. So at the end of this, slow will be pointing at len minus n nodes. Now what you can do, you can simply delete the next node, copy over those pointers and delete that node. Okay, and then simply return head. So I think like it is clear. Tell me if you have some doubt, guys. If that approach was clear, how we are doing it, then it is clear. So is it clear, guys? Tell me if it is clear. If you have any doubt, like a slightest of doubt, tell me now, or otherwise I will move to the next problem. Okay, no doubt. Okay, so let's go to the next problem for today. Okay, I will share the problem link with you guys in the chat. So let's look at this problem. So have you guys can you guys see my chat, like means the link which I sent you? Is that link visible to you guys? Okay, so this is the problem. So we are given k linked list which are sorted individually. I will just increase the font maybe. So we are given an array of k linked lists. Each linked list is sorted in ascending order. We have to merge all the linked list into one sorted linked list and return that list. So basically what you have to do is, so if we are given mm, a few linked lists like this, 1 4 4 and another list 2 6, so this will be null. Okay, I will write null here. Some of you might get confused, so I will just write null. What you have to do, we have to merge all these lists. So after merging, you have to merge them in sorted manner. This list will look like this: 1 1 2 3 4 4 5 6. Okay, so is the problem clear, guys? Tell me if it is clear or if you have some doubt. So all these lists are sorted individually. So I will show the problem to you. So after merging, this list will look like this, just as we saw. So we are given an empty list here. Just return an empty list. So we are given a list of empty lists, a list like we are given. So here it is given like we are given no linked list. That means it is empty. So if we return nothing, and here it is given a linked list containing just no node, just return nothing. Same. So doesn't it look like that merge sort? Like in merge sort, you are given two arrays. Like what you do in merge sort, you like sort the two arrays, like the left half and the right half, and then you have two sorted arrays. Now you try to combine them together. So here there are not two linked lists but k linked lists. So if there are two lists, then it would be just like merge sort. Two lists, just join them. Sort order. Yeah, divide and conquer. No, like we have to implement the merge procedure, kind of the merge procedure. The merge procedure doesn't have any divide and conquer. Divide and conquer is happening in the merge sort. Divide. Yes, we have to just implement this conquer part, like merging the conquer part of the approach, which means just the merge procedure. Merge all these k lists into a single list. So how do you think we can approach this? How can we solve this? So if there are two lists, what do you do? If there are two lists, just iterate, like keep a pointer to the lists p and q, and just iterate like one value at a time and merge them. Simple like merge sort. But here there are k lists, and compare each element to list. Yes, Shorav, you can do that. But how much time do you think that will take? So how much time do you think that will take? You can take k pointers. Okay. Yeah, perfectly valid. Like you are telling, like the approach we follow in merge, right? take 2 pointers. So here you take k pointers. So what we do, like in merge sort, like comparing 2 pointers is easy. We see if p1 is less than p2, right? If ARR of p1 is less than ARR of p2. But here you have to compare k values. So it will take k comparisons. So k comparisons would be very costly. We have to optimize that k comparisons. We want to do, like, we want to spend less amount of time in finding the minimum value. Sort of the approach you said is correct. I will agree. So let's see your approach first. Suppose you have k lists, L1, L2, L3 up to Lk. Okay, and suppose the first list have n1 elements, n2, n3. So others, you can think about an approach. How can you optimize that? Yeah, I will solve this problem. So basically I will have another session, like this is one more session. I will have a next session starting at 8 p.m. So maybe it will start at 8:05. I will give you a 5-minute break after 8, and we'll continue from this point where we end here. Okay, we'll solve like another few more hard problems and medium problems from LeetCode. So if you say that I first combine these two lists, the number of comparisons it will need is n1 plus n2 comparisons. Okay, now let's say this list is combined into one single list called p1. Now this is one list and this is another list. So now you compare these two lists, p1 and l3. It will become another sorted list. So how many comparisons will this take? This will take n1 plus n2 plus n3, right? Like comparing, just forming this p2 list. So now it will take, after that, n1 plus n2 plus n4, and finally, so basically what we will get is something like this: n1 plus n2 plus dot dot dot, and the last we will get plus nk. So if you call this entire thing n1 plus n2 plus nk equals to n, so this would be approximately n square time. If you call this n1 plus n2 plus n3 plus nk to be n, entire sum, that means there are like total n elements in the entire list, like in all the lists combined. So this sum would be approximately O of n square. But we want to do something better. And another approach which you said was L1, L2, LK, keep k pointers. Okay, k1, okay, not k1, let's give a better name. Okay, p1, p2, like pointing to the each list, pk. So now the problem here is, when you want to combine them, you want to find the minimum among all these, and minimum finding will take O of k time because there are k elements. And in total, if there are n elements, like this n1 plus n2 plus up to nk, if there are n elements, so each time you need to compare one, and that would take k time. So in total it would take O of n k time, right? Because to find one element we need to do like order of k comparisons. So we want something better than this. So think about which data structure we can use. The the problem here is this comparison. Say to combine n elements, each comparison is taking k time. That is why this factor k. So I want to just reduce this factor. Just reduce this factor. Like the time complexity should look somewhat like O of n into something. This should be less than k. How do you think we can compare k elements if we have k elements? If we have k elements to compare, how can we compare them in less than O of k time? Anyone, any idea? See, among these k elements, I just need to find the minimum. I just need to find the minimum because that minimum will be our next node, right? So if you look at this example, so the first node will be the minimum of this 1, 1 and 2 because this is already sorted. So if I put this node first, this node, now this pointer will move towards here. So now I have to compare what? This guy, and this guy. So now you see that this is the minimum. So it will be 1 again. Now you compare this node 2, 3, 4. So now you see that 2 is minimum. So at every point of time we need the minimum among them. Hash table will not do this job of maximum event on list. Hash table, how can hash table find the minimum among k elements? So you have these k elements, there are k lists. You want the minimum among this k list. Yeah, Mitesh, you can do that. So if you can use that, try to come up with an approach which solves this. So I will start the next class in 5 minutes, 8:05, and I am sending you the link in chat. So we'll be back in 5 minutes. Okay, in that time you can think about like how we can solve this problem.